Welcome everyone, and thank you for joining us today. Today's webinar is presented by Sports Field Management Association. This week, we will begin our four-part series of post-conference education. Our featured speaker today is Samuel Doak. Sam taught at Virginia Tech for 21 years before retiring in 2021. He taught classes in the associate's degree program, including several in turfgrass management, irrigation, soils and nutrient management, athletic field practicum, etc. He received his BS in business systems from Old Dominion University before seeing the error of his ways and received an MS in turfgrass management from Virginia Tech. He has worked many jobs, including operations for a major chemical company, managing shift work, building a 26-story building and houses and sales. The career he enjoyed the most was teaching at Virginia Tech. He enjoys any excuse to get on an athletic field, including playing, coaching, and refereeing NCAA soccer, rugby, and lacrosse. Today, he will be presenting pesticide and top dressing calculations. It's only cell phone math. A link to his session handout will be posted in the chat shortly. Attendees will be muted during the presentation. If you have any questions, please use the chat feature. Please type in your questions and Sam will answer them during the presentation. Sam, thank you for joining us today. You can go ahead and get started.
All right, thanks a lot. I appreciate it. I appreciate the Sports Field Management Association for letting me do this. We're going to be working through some problems, so it won't be like, oh, I got it. What do we have? You can use the hand thing, raise your hand sort of, because I'll sit there and say, work this. What are we going to have? It's a little harder that I can't sit there and say what goes on top of what. But when we do the problems and you've attempted to work through it, just kind of give me a little, little hand up on the box. We'll kind of get an idea of how many people are in there. Otherwise, I'm going to kind of guess at the timing, and we'll try to keep this moving along reasonably well to get you out of here on time. So, okay, we're going to go through wet and dry formulations, coming up with how much to apply. In the end, we'll do a little bit of top dressing. So first thing I do is get out your calculators, get out cell phones. Obviously, for those of us old enough to know what that thing in the middle is, that won't work well for a calculator. But get some scrap paper and pen just on the side to work, because really most of this is just doing it. So, and for all of us that are real old, we know what that is too. All right, so learning objectives, we're going to figure out how to calculate different amounts of wet and dry formulations. We'll talk a little bit about some of the important reasons why you need to be able to do that. Yes, you have to look at the labels and do other things, but you should have an idea of how this thing is calculated. And then we'll have a bunch of practice stuff in there. We'll give sort of my left-handed way. I'm not really going to try to do the 4 or 5 different ways there are to calculate this. As I'll say used to say to my students, if you know a way that makes more sense for you and you can come up with the right answers all the time, go for it. I'm not trying to change anybody's mind on how to do this, but this to me is just a simpler way to do it. I'm left-handed, so maybe that has something to do with it that way. But look at the ideas. If it's a little quicker for you, great. But if you've got a way that maybe takes a little bit longer, but it makes more sense to you, that's half the battle. If you can kind of logic your way through, I need to do this, then this, then this, that's a much better way of doing it rather than, oh my gosh, I need to memorize a formula. Because that way, in the long run, always fails. If you can sit there, I need to get this, and then do this, then you've got it. In any math problem, calculation problem, you should be able to talk your way through it before you even put any numbers in there. That's when you know you've got it. That's when you know you can teach it to other people. Right. And we'll cover a little bit of top dressing in there mercifully. Basic top dressing, we're not going to figure out how to fill all the aeration holes and all this. That's a whole nother hour worth of stuff we can do. but basically want you to run through this, practice it so you feel more confident that you can get the right answers to make this happen as you calculate as opposed to calculate stuff. Okay, we talked about inputs, raising the hand. Kristen's going to be in there to help out if I miss stuff in chats. And the biggest thing with this is practice. You have to sit down and practice. Use it or lose it, which is the same for anything in life. I always say, why worry now? We're only doing application stuff. Why worry? There's good song by Dire Straits. Well, why worry is partly there are rules and regulations that make you worry about it. There's the money issue because these things aren't cheap and you want to make sure you're getting the most bang for your buck. There's environmental concerns about I apply too much, I apply too little. What am I going to do? And then the CYA, cover your behind. This is a very litigious area we live in now. So if you do this and you can show them how you do it, you're covering your butt, And because you're the professional, you want to show that you are of value to your company, to your facility, that this is why you hired me. I'm the professional to do it. And hopefully above all in life and everything else, but you're doing it because it's the right thing to do. You have a way to do it. I won't read through all this, but just realize when you're using chemical applications to control things, it should be part of an IPM approach. It should be just one little section for all the other things that you want to do with this. The biggest thing I like about IPM, and this is just sort of my way of doing it, there are lots of other people, but is basically for IPM, why you're doing something. I am going to do this at a certain level. If there's just one insect, bam, put your hand on top of it, one insect down. If there's 50,000, I need to do some other stuff. But basically IPM, you should have this. And this just is, a little bit of knowledge. First, I'll go to the first couple, a little bit of knowledge, figure out when I should be looking for stuff. I mean, we're not looking for crabgrass now, but when should I be looking for crabgrass? When should I be looking, heaven forbid, we get cutworms again, like we had this fall. When do I look for those? And with that, when do I put on different controls? The other part is I'm scouting, I'm looking, I'm seeing what I have. If I have just a couple, maybe you don't have to do anything for it. But once I get to a certain level, now I need to do something. That's where the IPM, you have little trigger points of what you have to do. So somebody says, why are you doing X, Y, Z? Well, because of this, and this. And that's what you want to do to be the professional and be the go-to person to make that happen. Okay. Other thing you need to do anytime you're applying stuff, you need to calibrate and keep a record. Because you want to apply the perfect amount and you want to have proof that you're applying the perfect amount. Well, so-and-so and so-and-so did this. No, I did this and I put the right stuff on. Something else is going on in there. So again, covering yourself, getting the best outcome and again, mitigating all the other stuff in there. As I tell my students, oh man, I got to fill out paperwork. If you put 2 sheets of paper on your bottom and somebody kicks you, it hurts. If you've got 500 pieces of paper down there and they kick you, you won't feel it. So always keep records, do the paperwork. It pays off in the long run. When you're calibrating, again, knowing the basics, there are lots of different ways to do this. On the dry materials, you pretty much are figuring out an area. I'm going to drop it in 1,000 square feet. How much do I need to drop? I have a number. I'm going to go over that area. I'm going to put it in with 1,050, 200, whatever it is. I have a number. And then if I'm putting more, I make the opening smaller on dry. If I'm putting less, I make the opening bigger. When you're doing wet materials, you're really not getting a target amount that I'm trying to calibrate to. You're trying to figure out how much is being put out. How much is my sprayer putting out? How many gallons per acre am I putting out? If I'm putting out 50 gallons per acre and I got a 200-gallon spreader, I've got 4 acres I can work. If I'm doing backpack sprayer and a gallon in the backpack sprayer gives me 1,000 square feet, then I know what to do. So those are just the basic things, but you need to calibrate and then write down that you've gone through the calibration steps. And you've probably heard this over and over and over again. Read and follow all the label directions. It's the law and your responsibility. There's no if, ands, or buts about it. Always go over these things. I think that's probably why a lot of people use the same chemicals over and over again. They're comfortable with them. They've read it. They know what you can spray it on and what you can't spray it on. I've got a class I would teach. We would read labels and you're looking for things you can't spray it on. And they're hidden all over the label and all over the direction. So you really need to take time and plan this stuff out and look. Okay, enough said. Let's move on and figure out applications here. So two basic kinds of formulations. We've got the dry and the liquid. The dry, it's in a bag or a pouch. It pours out in chunks, granules, flowables, wet powders, all this other stuff. Liquid, it comes in a jug or it comes in that 30-gallon or whatever tank in there. So there's dry formulation and there's liquid formulations, and they calculate a little differently, as we'll see. So this is the one slide out of all slides. If you got to look at slide or take a screenshot of the slide, this is probably the one that summarizes the difference in there. Okay, dry formulas. The numbers on a dry formula are percentages, just like fertilizer. Fertilizer, if I've got 4600, I have 46% of the weight of the bag is the nitrogen in there. In this case, instead of nitrogen, we're looking for the active ingredient. So on dry formulations in bags and materials like that, it's coming in as formula. So if it says, if we've got a 50 DF dry flowable, it's dry, it's in a bag. It means 50% of the weight is active ingredient. And again, when you do 50, it's 0.5. You have to do the decimal, just like a 0050 fertilizer. And the calculations follow up exactly the same way. Instead of calculating percentage nitrogen or the amount of nitrogen putting down, I'm calculating the amount of active ingredient put down. So dry, just like fertilizer, it's that way. Now, the kicker is when we get to liquid, it changes. The numbers are the pounds of active ingredient per gallon. If you think about it, it makes sense. We're coming in a 2.5 gallon jug. We're not really going to sit there and do a percentage, because then we got to weigh the jug and figure out how much it is. It's much easier in liquid to figure out how much is in each gallon. And that's what they put in there. So a 4 EC is going to contain 4 pounds of active ingredient per gallon. So emulsifiable concentrate will have that. So if I've got a 2.5 gallon jug of a 4 EC, remember 4 pounds per gallon, that 2.5 gallon jug contains 10 pounds of active ingredient. 2.5 gallons times 4 pounds of active ingredient per gallon in there gives you 10 pounds. So liquid, the numbers are pounds of active ingredient per gallon. Percentages are, the dry stuff's going to be a percentage. So a 2.5 L liquid contains 2.5 pounds of active ingredient per gallon. Then you get the same thing down there. If I get a 2.5 gallon jug, it's 2.5 pounds of active ingredient per gallon. I've got 2.5 gallons. How much do I have in a jug? So, but we'll get into that a little bit more. But this is kind of the basic difference between wet and dry. If it's dry, it's just like fertilizer. If it comes in a jug or liquid, we're talking pounds of active ingredient per gallon, liquid gallon. Okay, so we'll start off with dry formulation, since it's closer to fertilizer and hopefully a little bit simpler. And you tend to run into this probably more often, as in you're having to do the application amounts. So it's a percentage in there. Numbers are the amount of active ingredient in the package by weight. So if I've got a 75 dry flowable, it means 75% of that package weight is active ingredient. So if I've got 100 pounds of the 75 dry flowable, I've got 100 times 0.75. You have to use a decimal. Can't just do the 75 of the percentage. You have to convert it to decimal in order to do anything mathematical with it. So 100-pound bag times 0.75 gives me 75 pounds of active ingredient in that package. You know, and they all change. How about this one? This weird one, we got 2.5 granular. It's in a bag, but 2.5, that's 2.5%. Oh my gosh, why even put it in? They put it in there. And the kicker on that is you see at the end there, 2% is going to be 0.02. So 2.5%, 0.025. And this is where most people mess up when they're doing this kind of calculation is, they'll just put 0.25. Well, that's 25%. So anything that's less than 10 on the percentages, you got to put that extra zero in there. Always, and think, when you're doing all these answers, does it make sense? If it says I need to put 500 gallons per acre, do you think your answer might be wrong? So always take a step, look back, does the answer make sense? You put it in the calculator will give you a number. Right or wrong, it doesn't know. It's up to you to figure out, does that number make sense? Take that 2 seconds or whatever it is and look at all your answers and go, okay, I believe it. And then move on. That will save you a lot of grief down the road. Okay, so my left-handed way of doing this is I'm going to divide the rate, whatever I want, so many pounds of active ingredient per acre. I'm going to divide that by the percentage of active ingredient. So if I had that 75, I need to use 0.75. So we have a division going here. So the way I remember what goes on top and what doesn't, I use the phrase here, want over have, because what I want is always above what I have. I want the dually 350, F350 diesel, and what you have is the Ford Ranger. So what you want is always above what you have. That's just a way of thinking about it. So when you do the division, what goes on top. Want, that's the rate. Rate over the percentage of active ingredient. Just like you're doing fertilizer. Fertilizer would be, the rate pounds of nitrogen per whatever divided by the percentage of nitrogen in the bag. So this is the rate. How much active ingredient do I want per area divided by the percentage of what's in the bag. Now, the key thing for this is I have to use a decimal. If I could do anything mathematical with a decimal or a percentage rather, I need to put it in decimal form. So all your percentages need to be in decimal form. If it's 75%, don't put 75. Put 0.75. Okay, so this just what I said there. Again, the way I remember it is want over have. Want is above what I have, so I'm going to put the rate. What I want to apply is my rate. What I have is my percentage of active ingredient in whatever I'm using. And the only tricky thing is the active ingredient must be in decimal. And if you do that, then all your decimals, there you go, 0.75, 23, and if I had a space in there, 10%, 0.1, and then the odd ones are when you get the single digits, you need to remember to put the zero in there. All right. Now, also when you do the rate, you're looking at for an answer. If my rate is in pounds per acre, my answer will be in pounds of product per acre. When you do the math, the acre or whatever the area is stays there. If my rate is in ounces of active ingredient per 1,000 square foot, guess what? My answer will be ounces of product per 1,000 square feet. So if my rate's per acre, answer will be in per acre. If it's in per hectare, the answer will be per hectare. In widgets, it'll be per widget. So far, so good. Kind of hard not seeing faces in this to know what kind of looks am I getting? You get that deer in headlights, or we're going to, we'll blaze on. All right, so this is where you get your calculators, your phone out. Let's start working on some of these dry formulas and get away through it. We want to apply 1 pound of active ingredient per acre. That's my rate, right? Remember, that's the want. That's what goes up on top. So what number are we going to put up there? 1. That's all we need to do. And I have a 75 granular. So again, it's dry, it's in a bag, it's going to be a percentage. So 75% is what in decimal? Hopefully you've all got this. It's hard doing not seeing this, but this is how we'd set it up. So want over half. So the rate's above the percentage. We want 1 pound of active ingredient per acre. I know my answer will be in per acre. And I've got 0.75, that's 75%. And I end up with 1.33 pounds of product, because that's our whole thing, is I'm trying to find out how much product to put down to get that rate. And just like in a fertilizer, if my rate is 1 pound, do I need to put down more than 1 pound of the product to get the 1 pound of active ingredient, or to get the 1 pound of nitrogen? The answer is, oh, heck yeah. So if your answer ever comes up to being less than the rate, if my answer came up to being less than 1, then I know I've got it wrong. So if I've got 1.33 pounds of product per acre, how much for 10 acres? What do I need to do? Multiply it by 10. If 1 is 1.3, I just multiply it by 10, and that's how I come up with how much product per 10 acres. Okay. Another one. This time I want to put down 0.25 ounces per 1,000 square feet. And I know that my answer will now be in ounces per 1,000 square feet, because that's what my rate is. And I have a 40 wet dispersible granule. Pardon me, I know that's not exactly right. But we're going to set the math. What goes up on top? My rate. That's going to be 0.25 per 1,000. And what's going to go on bottom? Remember, it has to be in decimal, so 0.4. So I know my answer needs to be more than 0.25 in there. So rate over percentage, what I have here, and then I know my answer will be ounces of product per 1,000, because that's what my rate is. My rate was ounces of active ingredient per 1,000. My answer, but I do the math as I'm figuring how many ounces of product do I need per 1,000 square feet. Hopefully good so far. Okay. How much if I wanted 25,000 square feet? Yeah, multiply it by 25. I know how much for 1,000, how much for 25,000. Well, 1,000 goes into 25,000 25 times, so multiply it by 25, and that's what we're going to get. And again, ounces. So not a lot. A lot of the granular, the wettable stuff actually is made to go into a tank, but you still have to figure out the dry weight to put it in there. All right, so got some of these up here. I have a Dimension Ultra 40 wettable powder. It's still a powder, it's dry, which 40 means it's 40%. I want to put down 1/2 pound of active ingredient per acre. How much product do I need? Well, I know my answer will be pounds of product per acre. And I have the want over have. So what's going to go on top? Want is going to be my rate, the 0.5 pounds of active ingredient per acre. I tell students, try not to do a shortcut. If you write all that out, I realize it's a lot of work to write, pounds of active ingredient per acre, but then you realize when you look at your answer, instead of just having a number, you could put a unit with that, is in, pounds of product per acre. So what, and also what's going to go on the bottom? I've got a 40 WP, 40%, 0.40, I'm going to put on there. And I know my answer needs to be bigger than my rate. Rate's 1/2 pound, so I know it has to be larger than that. So 0.5 pounds of active ingredient per acre, 0.4 because it's a 40 WP down to 40%. It's going to give me 1.5 pounds of product per acre. How do I know it's 1.5 pounds of product per acre? Because my rate is in per acre. Again, just the same as if we were doing nitrogen fertilizer, it'd be the same thing. Okay, so let's go down to this one. A 75 dry flowable, 75% active ingredient because it's dry. I want to put down 1 pound of active ingredient per acre. So I know my answer will be in pounds of product per acre, because this is pounds per acre, right? Okay, want over half. So what's going to go on top? Write it down. What's going to go on bottom? Remember to put the decimal in there, because if you don't put the decimal, you end up with something way smaller than that. So if I had 1 divided by 75, my answer would be a whole lot less than my rate. And I know I've got it wrong. I'll go back and someone says, ding, 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 need to change this. Check it out. Make sure we got it. Okay. So 1 divided by 0.75, because it's 75% active ingredient. Going to put in here, the rate goes up on top. This is per acre. I know mine will be pound of product per acre. There we go. Like a 75 nitrogen fertilizer. Oh, like we could actually find a dry one like that to make it happen. All right. We get Balaton on here. 50 WSG. So 50% active ingredient by weight because it's dry. I want to spread 0.4 pounds of active ingredient per acre. Again, want over half. What's going to go up on top? The rate. So 0.4 is going to go on top. What's going to go on bottom? The percentage, but in decimal form. And we know it'll be pounds of product per acre because that's what the rate is. So there we go. Hopefully everybody's doing good. Nobody's head's gonna explode yet. Okay. All right. So again, this is the practice part. And if I'm going too fast on these things, please put in the chat, slow down, give you more time in between, because you really do need to kind of work this and see this for yourself to make it happen. All right. These are a little funkier because here we go. We've got pendulum 2G. So that's 2% active ingredient, 2%, ding, 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 less than 10. So what do we need to do in the percent? Put a 0 in there. It's not going to be 0.2. 0.2 is 20%, so 0.02. I want to spread 3 pounds of active ingredient per acre. So I know my answer will be pounds of product per acre. And I better put a lot of it because this is only 2% in a pound. That's going to be a lot of pounds to make up 3 pounds of this. So want over half. What's going to go on top? My rate's going to go up on top. And what's going to go on bottom? In percentage. But again, this is going to be tricky. You got to realize it's going to take an awful lot of product to get up with this. If this came up with 15 pounds, you might think, 2%. 15 pounds, 2%, that's not going to be enough to make that happen. So look at it. Again, look at your answers before you move on. Does it make sense? All right, next one. Again, single digit 6.2 G, granular form, 6.2% active ingredient. I'm going to put 0.18 pounds active ingredient per 1,000 square feet. So what are going to be the units of my answer? 1,000 square feet, pounds per 1,000 square feet. So I can almost put the want over half and put a line for the answer, and behind that put pounds of product per 1,000 square feet because that's what the rate says. So we do it, 1.8, answer is bigger than my rate here. So I feel better about that. And I'm putting it in here. And 2.9 pounds of product per 1,000 square feet. Again, does that seem reasonable? You know, if I had said 29, or if I had, heaven forbid, I said 290 pounds of product per 1,000 square feet, you might think, wait a minute. And if you don't, I want a husband. There is profit to be made there. So that's why you want to go over this, so you know when you're coming up and you're doing your budgets, here's what I need for the year, about. All right. Even this is a tougher one. This is the tricky one. What if I've got 0.25 G? That's 0.25%. That's not 2%. That's not 20%. That's 20.25. 1/4% is what we have to put in there. oh my gosh, if I needed to add 1 0 for, a less than 10%, what do I have to do if I'm 0.25? Yeah, add two zeros in there. We have 1 over half, I want half a pound AI per acre, 0.0025, because this is 0.25 G. So 0.25%, that's what we have to do here. That's the only tricky thing about this. And then we come up with 200 pounds of product per acre, and you realize that sort of kind of makes sense. If I had to spread, if I did it wrong and just put only 1 0, I'm going to end up with 20 pounds of product per acre. And you can look at that and see, man, that's going to be a bugger to try to spread 20 pounds per acre. Get out the tweezer, right? 2 steps of drop, So again, look at the answer. Does it sort of kind of make sense? You always want to run that through. All right. So practice problems for you. So go ahead and work these out. If you haven't worked the other ones out, we're going to take a little bit of time and work these out. So pendulum 2G, even telling you, because it's granular, it's dry, it's 2% active ingredient. Ding, 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 less than 10%, 2%. You got to do something different with it. And I want to put down 1.5 pounds of active ingredient per acre. So I know my answer will be in pounds of product per acre. So go ahead and work that one out. We know want over half. Want is going to be my rate. The 1.5 pounds of active ingredient per acre. I have a 2% active ingredient dry product. So I need to put 2% in decimal form in the bottom. And what are you going to come up with? No, that's not T, I'm teaching. Yes, it is T. All right, so this is what you have. Hopefully you had 75 in it. Let's do it again for the next one, 12G. Hopefully you're just cycling through all these and you are so far ahead of me, it's not funny. 12%, 12G, so it's 12% active ingredient. I want 4 ounces of active ingredient per 1,000. So on this, ding, 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 per 1,000. So my answer will be in ounces per 1,000, because that's exactly what the rate is. The rate's going to give you active ingredient. The answer will give you product. So I want product in there. So on top is the 4 ounces per 1,000. Bottom is the 12%. Again, in decimal. I know my answer has to be more than 4, because there's no such thing as 100% active ingredient or like 100% nitrogen on anything. So I always need more product than I have rate. The other one, 5% active ingredient. And I want to put 1 pound of active ingredient per acre. So you're realizing, 5%, and I want 1 pound. That's going to be a little bit in there. So again, want over have, because want is above what I have. Just a way to remember the numerator, the denominator. What goes on top is want. What goes on the bottom is have. Have is what I have is my product. What I want is my rate. So I'll put those in. And that's what you get. And there's the other one, 0.35. So that's 0.35%. And yeah, they make stuff out there like that. It usually gets mixed in. It's sort of like a wettable powder to get mixed in with something, but I still need to figure out how much to put in there. All right. Thank you. This is working with math and trying to make this simpler. I am way too simple to do all the complicated stuff. Again, there are lots of ways to do it. This is mine. I think it's easier. Okay, so if I get dry formulas, then you could also do any kind of nitrogen or potassium or whatever, because they're all percentages. It sets up the same way. Want over have gives me product. Okay, so we get back on here. Click. Now, sometimes getting pounds isn't always the best way. If you especially you're trying to scale this thing out, you look in your scale, it's like, man, I don't have tenths of a pound. Like in this one, I have 4.4 pounds active ingredient per acre. I've got a 50% product. I end up with 0.8 pounds of product per acre. Obviously, this is something that's going to be mixed in a tank. You weigh it out and you put it in a sprayer. That's why it's so small. But my scale doesn't do this. My scale just does ounces. So how do I convert pounds into dry ounces? Wet ounces are different. Dry, if I'm doing granular, you have to remember that 16 ounces is 1 pound. So 16 ounces, 1 pound, and this is what I have. So what do I need to do? I need to multiply the pounds by how many ounces are in a pound, 16, and gives me the number. And you can figure out you're going the right way because you know the number has to get bigger. I'm going from one big box of a pound into 16 little boxes of ounces. So I know the number has to be bigger than when I started off with. So if I get 8/10, I know it's got to be bigger. So if I do something wrong and that number gets smaller in ounces, you know you've made a mistake. So again, look at it. Does it sort of kind of make sense? And you're realizing 0.8, that's 80% of 16. Does the 12.5 look about right? Yeah. I mean, you don't have to sit there and do the exact math, but you're sitting going, oh, 80% of 16, 12.5, I believe it. Now, if I came up with 1.28 ounces and you're sitting there going, man, that's going to be 80% of 16, you'd realize that's probably not right. I need to go back and look. But in these others, you're in the ballpark. That looks good. I believe it. If you believe it, move on and go on to the next one. Yeah, we all know the feeling. So are there, if we stop right here, are there any questions you've got? We'll do this just a little bit. Anything in chat? People still here? Oh my gosh, I am way too comfortable in the couch. All right. So let's go on to liquid formulas. Dry is a percentage. Liquid is something completely different. And this is where people mess up and they try doing it exactly the same way. It sets up with the same 1/2, but the numbers are different because the formulations are different. The formulations are not percentages. The formulation are in pounds of active ingredient per gallon. So your answer is going to have to be in product, how many gallons of product, because your active ingredients can be in active AI per gallon. So your answer needs to be in per gallon. And if you think about it, it makes sense. I've got a jug of product sitting here. I'm not going to put it in a cup and weigh it out, am I? No, the answer, if I get a liquid product, the answer needs to be a liquid measurement. And that liquid measurement will be gallons. We can change that into ounces later on. We'll do that. But just realize liquid product needs a liquid measurement at the end. So if I have something of 4 emulsifiable concentrate, 4 pounds of AI per gallon, just like we said before, if I get a 2.5 gallon jug of a 4 EC, 4 pounds per gallon, 2.5 gallons, I end up with 10 pounds in that jug. Then 2.5 liquid. Again, it's in the jug sloshing around, 2.5 pounds of active ingredient per gallon. So if I've got a 2.5 gallon jug of a 2.5, this is going to be 2.5 gallons times 2.5 ounce of AI per gallon is going to give me 5 pounds in that 2.5 pound jug. Just how it works. And partly you could look at that and going, well, we'll see down here. If I need a certain amount, is it more than a gallon or less than a gallon? If I've got a 2 EC, 2 pounds of active ingredient per gallon, and I want to put down 3 pounds of active ingredient, I need more than 1 gallon. So again, you're using that when you're trying to figure out your answer. Before you even kind of do any of the math on it, you can sit there and go, oh, I need more than a gallon. I need less than a gallon. You can kind of eyeball your answer close. Okay, so the same, want over have, rate over what you have, except the rate is pounds of active ingredient per gallon. So rate how much AI, how many pounds of AI I want. On the bottom is going to be AI per gallon. My answer is going to be in gallons. The nice thing about this is you use the exact number. So if I want 1 pound of active ingredient per acre, and I have a 2 EC, 2 means I've got 2 pounds of active ingredient per gallon. So if I want 1 pound, and I've got 2 pounds of active ingredient per gallon, do I need more than a gallon or less than a gallon? Less, because I got 2 pounds of active ingredient in 1 gallon. I only want 1. So that's what you set up. And just you could almost do that. Yeah, go, I need half a gallon. Well, yeah, here's how it works out. You put 1 pound of active ingredient per gallon. I've got 2 pounds one pound of active ingredient, per acre is what I want. Down here, I put 2. So 1 over 2 gives me 0.5. And I know the answer will be gallons of product. And again, per acre, because this says per acre. Answer C, because this is per gallon, my answers will always be in gallons. Always, always, always. The area may change. It could be per hectare, it could be per 1,000, but the answer will always be in gallons because this is always given in gallons. Okay, so let's work some of these. I have a 3 EC, so emulsifiable concentrate, 3 pounds of active ingredient per gallon. I want up here. I'm cheating. If I wanted 3 pounds of active ingredient per acre, what would I need? Well, 3 pounds of active ingredient per gallon. I want 3 pounds. I would need 1 gallon. My mistake on here is I had changed the rate to if I wanted 1 pound of active ingredient and I have 3 pounds in there. Again, ask yourself, if I wanted 1 pound and I've got 3 pounds per gallon, do I need more than 1 gallon or less than 1 gallon? You said to go, I just need 1. I got 3 per gallon. That's less. So when you look at the answer, it would come up with less. Again, that's a goof on that one, but 3 and 3, I need 1. If I want 1 pound and I have 3 pounds per gallon, I'm going to need less than a gallon, 1/3 of a gallon per acre. How do I know it's per acre? Because this said it's per acre, right? Gallons will always be there. Per whatever will be back here. All right. So I've got prodiamine. I've got 4 flowable. So it means it has 4 pounds of active ingredient per gallon. So 4 pounds per gallon. The rate is 1.5 pounds of active ingredient per gallon. So I want over half. So what do I have to put on top? I need to put my rate on top, and I need to put my 4 on the bottom. So with this, I want 1 pound. I got 4 per gallon. Do I need more than a gallon or less than a gallon? So you come up with, I know about what the answer will be. Sometimes they work out nice and tidy like this. Sometimes they don't, but you know you're kind of in the ballpark. So always, always look at the answer. Does it kind of make sense? All right, this last one, I've got 1.3 L, so 1.3 pounds of active ingredient per gallon. I want 3/4 of a pound per acre. How much product do I need? And again, you can think on this. Do I need more than a gallon or less than a gallon? I want 1.3 pounds. I mean, I want 0.75 pounds. And I have 1.3 per gallon. I need less than a gallon. So when you come up with the answer, I'm going to put the rate 0.75 over what I have, 1.3. Again, you're just directly putting the number down here. No percentages, just put whatever the number is, put it down there. And the answer will be gallons of product. And then per whatever the unit is here in your rate. Your rate here is per acre. The answer here will be per acre. Okay. So sometimes you come up with these weird answers. And again, trying to look at cylinder and oh my gosh, it doesn't tell me this is 1/3 of a gallon or 0.4 of a gallon. You need to convert it into ounces. What you have to remember is that fluid ounces are not the same as dry ounces. I really wish they didn't use ounces, but they use it in both of them. Fluid ounces is 128 ounces per gallon. So you're getting the oh, thank you, Keith. So you're getting, a gallon of milk is 128 ounces. But you have to remember, if I want, my answer says 0.33 gallons, that's going to be really hard to kind of measure. You don't have a measuring container that says that. You're probably got to put it in ounces. So in order to put it in ounces, I get my into gallons, and I multiply it by how many ounces are in 1 gallon. And then I will come up. Again, per acre, answer here is going to be per acre. You're not changing the area I'm putting it over. I'm just taking it out of gallons and putting it down into ounces. Kind of, sort of, kind of. Oops. I just clipped on something here. 2.5, 2.5. Yeah, thanks, Bill. Hold on. See if I can. There we go. Sorry, I just went into chat and minimize chat. Let me go somewhere here to get something a little small. There we go. Let me pull. The problem is if when I pull chat up on mine, I block out some stuff. And it says, going back to dry, what if dry fertilizer says normal feeding is 4.76 per thousand? I'm assuming that's 4.76 pounds per thousand. And the product is a 2210. Can this be calculated? Well, if you're doing nitrogen, what you want is going to be up on top the rate, which in this case, I'm assuming it's 4.76 pounds per thousand. So my answer will be pounds of product per thousand. And if I'm doing the nitrogen, on the bottom will be the percentage because it's dry. So it'll be 0.2. So your number will be bigger than the 4.7 by a factor of 5. So what's our answer going to be there? 23, 25, something like that. And again, you could do the same thing if your rate's 4.75 pounds of phosphorus, then it's 2%. So on the bottom would be 0.02, and your number would come up that way. So yeah, that same, if you're doing dry, it's an active ingredient. It's the same as doing fertilizer. You just have to put in whatever you're looking for, NP or K or something else, and put that percentage on the bottom. Okay, so back to gallons here, liquid stuff, where we have pounds of gallon per acre. The answer is always coming out in gallons. So a lot of times you have to convert gallons into ounces because that's what you got to put up on your cylinder, your little thing with the marks, measuring cup with the marks on it, because it's going to be ounces. Yeah, on here, I'm sorry, I'm kind of doing the teacher geeky thing when you say 42.24 ounces. Yeah, I'm going to hold this up and go 42.24, ish. Again, this is you round it up to like right around 42, right? 42 and some drops, and that's what you're getting, unless you've got a big old syringe that you can measure off that close into it. All right, so let's go. All right, so how about this one? I have a 4F. Yeah, bet it around down or break it down. Yeah, I mean, this is all these answers are coming up as the math answer. The math answer gives you something to start, then you have to put it into the real world, how you apply this. So when we do top dressing, you see we need 39.56 cubic feet. Well, you're probably just round it up to 40, or maybe even bump it up a little bit more, because there'll be a certain amount lost. So these are the numbers in here. When you're actually doing the measurement, you're the one who has to decide which way you want to go with it. Okay. So on this one, I want 1 pound of active ingredient per acre. I've got 4 pounds. I need 0.25 gallons. How do I convert that into ounces? Again, 128 ounces per fluid ounces per gallon. So I can take that, multiply it by 128. And again, we're thinking, it's a quart, 32 ounces. So that works out well. How about the other one we've worked out? I have 1.3 L, so 1.3 pounds of active ingredient per gallon. I want 0.75. Again, I'm looking at that going, 1.75, that's less than my number, so I need less than 1 gallon. I put it in 0.577. If you've got a calculator, decimals are cheap. Use 3 or 4 places until you get to your final answer, and then you can squish up. So we have this, and you end up with 73.86. You're going to round it to 74. But don't throw out your decimals early. Keep your decimals, round your final answer that you need to do something with. That's when you round it. Until then, keep as many decimals as you can in there. Again, calculators, your decimals are cheap. Use that computer between your ears to figure out what you need to do with the back ones. All right. So this is where you get to work on some of these, and I get a sip of my tea again. So good stuff. 2.5 EC. What does that mean? I got 2.5 pounds per gallon active ingredient per gallon. I want to apply 2 pounds of active ingredient per gallon. Do I need more than a gallon or less? I got 2.5 active ingredient per gallon. I want to put 2 down. Do I need more than a gallon or less than a gallon? That's kind of the question you're asking yourself, because that way, when you look at your answer, does it make sense? That's really what you want to do. Take that 2 seconds and look, does it make sense? So go ahead and work on, we got want over have. Want is my rate, 2 pounds of active ingredient per acre. So my answer will be in gallons per acre. I have 2.5. So this is liquid. So that 2.5 goes straight down to the bottom. No changing percentages like you do on dry. On wet, that same number goes to the bottom. I come up with gallons. And then I'm going to multiply that by what to get fluid ounces? 128, because 128 ounces is in a gallon. And that's what I come up with. Hopefully that's what y'all come up with too. Any errors are purely here just to see if you're paying attention and you're not asleep. Again, if you believe that one, I'll sell you some land at low tide. All right, next one. So I've got 1.25 L, so 1.25, 1.25 pounds of active ingredient in a gallon, and I'm going to put down 2 pounds of active ingredient per acre. So I got 1.25 in a gallon. I want 2. Do I need more than 1 gallon? Less than 2? I mean, you can sort of ish your answer. And then when you come up with your answer, you know you got it right. Because if you miss it, you miss it big. You really miss it big. So if I'm even in the ballpark, I'm right. So I come up with 1.6, multiply that by 128, gives me ounces. And again, the rounding. This other one, 0.15 emulsifiable concentrate. Again, I have 0.15 pounds per gallon. I want 0.01, oh my gosh, pounds per. So I end up with itty bitty little amount. And yeah, you do the number and you crank it, but you're sitting going, man, I'm not going to use as much, am I? Oh, heck no. It's like, a tenth, 0.5, and I get a 0 in there. So there's about a 10-fold difference in there. So I know it'll be about a tenth of a gallon-ish, close to it, maybe a little less. So answer comes up and I multiply it, and that's what you get. That's the last tricky one. All right, so this one I was hoping we'd actually get some answers. Let me kind of go. I've got some minutes to do top dressing. And again, top dressing is, well, first of all, any questions on the liquid before I go blazing on here like I actually know what I'm doing? Wait. Okay. All right, so let's do top dressing. And we're just applying, when we're doing top dressing, we're just talking about applying a layer on the top. We're not applying filling holes or doing any of the other stuff. We're just on the top. And there really are 2 steps to this. The first one's the tricky one, because if you're dealing with golf or turf grass, you're always given how thick you want to put your top dressing on there in less than 1 inch. I want a 1/2 inch. I want 9/16. I want 3/8. And your area, you almost always are given your area, you know, 5,000 square feet, 2,500 square feet, 140,000 square feet. But in order to get volume is feet cubed. So I need feet squared, which is my area. How many square feet do I have? And then I have to multiply that by how many feet thick this is, not how many inches, how many feet thick it is. That's where people get hung up. So I got to convert my thickness into feet. I got to convert that 1/2 inch into feet. And once I do that, then I just multiply it by the area I'm dealing with, and life is wonderful. Okay, so everything has to be thickness, has to be, or depth, whatever you want to call it, has to be in feet. So what I need to do is I'll convert, if I get a 1/2 inch, I need to convert that into a decimal, unless you've got a really fancy calculator that lets you do that. But most of us, we need to put it in decimal in order to put it in a calculator. So 1/2 inch to 1 divided by 2 gives me 0.538. 3 divided by 8, that's all the slash mark means, is that's the division. 3/16 is just going to be a division. Give me into decimal, and all I'm doing is still inches. All I'm doing is taking it from the, you know, the fraction and putting it into a decimal. It's still inches. I need to convert inches into feet. Now, is that number going to get bigger or smaller? Like how many inches in a feet? It can be bigger or smaller. 1 inch is what part of 1 foot? That could be a big number or small. It's going to be a small number. So, and because I've got 12 in there, you need to take your inches and divide it by 12. Sounds great until you actually do it. And then you look at these numbers down here. It's like, you know, holy cow, are you kidding me? Well, that's 1/2 divided by 12. That's what it is in feet. You know, 0.04. So I gotta have a calculator that's got like 3 decimals on it, 4 decimals. I mean, the 2 ones will do it as long as you keep it straight in there. Otherwise, if you put in whatever number they give you, you lose all this down here. And you really like to keep it out to 4 decimals, because I'm going to have to break it down into 3, then break it down into 2. So the more you start with, the more accurate it is, the better it is when you break it down at the end. Because you can see if you round, you can do some of these examples later on. And if you round up by just using 2 numbers, you can see your final answer at times can be really, really big. The bigger the area, the more you need the decimals, because that little error per foot compounds by 100,000, 200,000, 300,000. It can really make a difference. So use the decimals in here. And just remember, when I take whatever these numbers are and I divide it by 12, I'm going to end up with this, oh my gosh, itty bitty, but I'm now in feet. 0.01, 0.04, it's going to be a small number. So just be prepared for it. But once you get that, you've got the hard part done. Then after that, I'm going to take my thickness in feet, because I've divided the inches by 12 and got that itty bitty teeny tiny number. And then I'm going to take it by the area, and I'm going to get volume. Feet times feet squared gives me cubic feet. Cubic feet are volume. So let's do a couple of these in here. How much top dressing is needed to put a 1/2 inch over 25,000 square feet? So what do we need to do first? We need to convert the thickness, how much, a 1/2 inch, into feet. So I got 1/2, 0.5. What do I need? And that's still 0.5. That's just a decimal, but that's an inch. So what do I need to do to make that inch into feet? Is that number going to get big or small? It's going to get OMG, teeny tiny little small. And once I have that, 1/2 inch into this divided by 12. Oh my gosh, are you kidding me? But it's now feet. So up here it's inches, and it's now divided by 12. It's into feet. And then I just take the thickness divided by the area, because it's 25,000 square feet. Then I get my answer. And just, keep it out that way. Again, we're talking 2 decimal places. When you actually go to buy or purchase stuff, you round it any way you want to. I mean, if 1,000 You go to the store and you say, I want 1,041.7 cubic feet. They can look at you and go like, right. But you sit there and maybe I want 1,050 feet. Maybe I want a little bigger because I know there's going to be slop off the wheelbarrows and all the other stuff. But you make that decision. Here's your answer. You apply that answer to the real world with what you need to do. Okay. Let's do a couple more up here. We got 3/16 of an inch over 5,000 square feet. And we did 3/16, 16 into 3 gives me this number here. What's the next thing I need to do? Because that's still inches. I need to make feet. So I do divide it by 12. Am I going to get an itty bitty number? Oh, hell yeah. But what do I do with that itty bitty number? I got thickness, feet times feet squared gives me cubic feet. And now if you're doing landscaping, mercifully, you don't have to deal with the inches. You can deal with this. 3 is still 3 feet, but it's still inches. I need to divide that by 12 to make it feet. So 0.25 feet. So same thing. I got my thickness, made it decimal. Well, 3 is already decimal, 3.5, 4, all those are decimals. So all you do is divide it by 12, make it into feet because you know this is going to get smaller. And then multiply it by the area. Thickness, feet by area feet gives me cubic feet that way. So the whole key to this thing is just getting it into the thickness into feet. So work on these. I want 9/16 of an inch over 35,000 square feet. So got to make 9/16 into a decimal. And then once I do that, what do I need to do to convert that inches into feet? You might come up with a small number. Yeah, so don't be freaked out by seeing the small number. You know it's going to be small. And I just multiply it by the area. Inches into 16 into 9 gives me this. It's still inches. Divide that by 12 gives this itty bitty number by feet times the area, because I know it's 35,000 square feet. And that's what I have. So how about the next one? I want 2.5 inches over 2,000 square feet. We get the, heaven forbid, do not do the mulch volcano, right? That's what I learned in landscape. I like the short grass, the short plants like grass better, but I have seen, it's amazing how many mulch volcanoes you'll get. So they must do something. So 2.5 inches. 2.5 to convert to decimal, it's 2.5. So what do I need to do to make 2.5 inches into feet? Divide by 12 and then multiply it. Is going to be a small number. Yeah. Then multiply it by 2,000. So that's how we get cubic feet. Easy peasy. Once you remember, I need thickness in feet. What do I need to do? I need to divide it by 12. If you just remember that, then the making it a decimal, that kind of comes naturally. I need to make my thickness into feet. I need to take that number, divide it by 12, and then multiply it by, it gives me feet, then multiply it by the square feet I have, and that will give me cubic feet. That's my volume I need. Of course, last thing we'll do here is just let you know that if I need cubic feet, a lot of times they sell the stuff by cubic yards. Oh my gosh, I'm taking these little blocks and putting them into a bigger box, right? So the number has to be, if I'm starting off with 1,640, I know my number needs to get smaller. So I'm realizing, okay, I can believe that. If the number gets bigger, you multiply it by 27. It's like, wait a minute, that's not right. Cubic feet are so much smaller than this. And if you want to memorize, it's 27. I never can, but you realize the box is 3 feet by 3 feet by 3 feet. So 3 times 3 times 3 is 27. If you wanted to figure out how many cubic inches, it'd be 12 by 12 by 12. What's that? 1728. I'm trying to remember this. But most of the time for doing top dressing, I just need to make it cubic feet. So take my cubic feet I figured out, divide it by 27. If you don't remember how to don't remember the 27, you just go 3 by 3 is 9 times 3 is 27. Oh, 27 blocks go into, that's it. And so that's really all that is. You get your cubic feet divided by yards. And again, I'm coming up with a 60.67, 15.43. That's what you need. If everything works perfectly, you're going to have to run it through the computer between your ears going like, well, I need 61, or I know my crew, so I better get 62, yards, or what the heck, the truck holds 65, just get me a whole truck, but you know what you need, and you figure out what overage or whatever you have. This gives you the mathematical answer. You just need to see the mathematical answer and then translate that into real world with what you need. All right. With that, only a little bit over. Hopefully you all aren't quite like this. It's kind of hard to get feedback on it, but we get copies of questions. But you get questions, feedback, put them in the chat. I'll be happy to answer whatever I can. There's my email address up there. Y'all can shoot me an email. Heck, I'm retired, like I have anything else to do other than repairs on a house and pool and all the other good stuff. But I always do look forward to answering questions and things. With that, I thank you very much and look forward to your questions.
All right, thank you, Sam. If you guys have any questions, like he said, you can enter those into the chat. It looks like Frederick has a question about pesticide credits. We are not offering them for Maryland. If you need to apply for those credits, you're responsible for getting in touch with your State Department of Agriculture. Again, Sam's information is there on the screen if you have any additional questions. Thank you, Sam. Thank you all for joining us today. Don't miss the presentations featured each Tuesday for the next 3 weeks. Check the SFMA website and your email so that you can get registered for those sessions. Thank you, everyone, and have a great rest of the week.